we have here, and this is something called the North Bridge, South Bridge architecture. Now, the principle of data here is that CPU needs to use data, doesn't it? In order to access that data, where could that data reside? It can reside in the slowest and worst possible case on the floppy drive. Okay, so it could be down there. Or it could be on a hard disk attached to an enhanced IDE controller. If it's not there, where else could it be? Well, it could be in RAM, so the data may be accessed there, or it could be in the level 2 cache. So the CPU says, hey, I need XYZ data to process this instruction set that I'm supposed to do. Where's it going to look? Well, it'll look in L1 cache, which I'm not really addressing directly here, but that's usually integrated directly into the CPU. And if it doesn't find it there, it'll go to L2 cache. But guess what? If it's in L2 cache, it has to go across what we call the backside bus here. So in order to access that level 2 cache, which is a slower form of memory than L1 cache, then going through the backside bus, we would hope that this backside bus would be very fast. Okay, because the faster the backside bus, the faster our access to L2 cache. If it's not there, though, it has to go through our North Bridge architecture. And this is just a logical diagram, of course, of a North Bridge, South Bridge architecture. But going through the North Bridge here, which is a series of integrated circuits and components here, then it can access the random access memory, or RAM. But again, if it has to access RAM, then it's got to go through this North Bridge architecture, and since it has to go the long way around to access the data, even though RAM is extremely fast, almost inconceivable in human terms, in computing terms, that's pretty slow to have to go through the North Bridge if it has to go through there. Also notice that another thing that competes for attention on the North Bridge here would be the AGP video controller. And this all takes place across a front side bus. So again, also, we want our front side bus to be as fast as possible as well, so we can shovel data back and forth between RAM and our video. Now, if it can't find its data in any of these locations here, of course, now it has to go down here through the PCI bus. And the PCI bus handles all the remainder of the traffic throughout the system and all of the peripherals. For example, if we have something on a PCI slot, that of course goes through the PCI bus. If we have an ISA slot, these are pretty much defunct, as I mentioned earlier, so I'll just kind of X these out. But for argument's sake, at least, if it had an ISA slot, it would have to go through the PCI bus, then through the South Bridge onto the ISA bus, and then all of our other peripherals, which explain themselves right through here, also go through the South Bridge. Now, here's the problem. We have a lot of data going through the South Bridge and then through the PCI bus in order to be able to access things. So if we're multitasking heavily and we're doing something that's very disk intensive here on IDE 1, and then we're burning a CD or a DVD on IDE 2, and we're also accessing data on the floppy drive, and we're retrieving data on an external hard drive through a USB port, well, you can see where this is going. There's a lot of things going on there, and that South Bridge is very, very busy, and then trying to shovel a lot of information on through up here to the CPU. So when this architecture first came out, it seemed pretty good, but I think a lot of times these designers never realized how busy the average user would actually get doing a lot of different things, burning DVDs and CDs and working with Photoshop or disk-intensive applications and so forth. So the North Bridge, South Bridge architecture, although in concept, is still something that works and that we still use. In terms of actual implementation, this has largely been abandoned in favor of other technology. And incidentally, here I'm on a new diagram, but that previous diagram, you don't need to memorize that or all the components to it, but get the general thumbnail idea. And the same is true of this. What I want to show you is, with the CPU, current CPUs, the level 1 and level 2 cache are usually integrated into the same housing as the chip, or much, much closer, so they're not separated now by another bus, like that backside bus. Now we have these level 1 and level 2 caches very, very close, so that's going to be faster just by the architecture of the chip. And then if we have to access RAM, we now go through a memory controller hub, or sometimes they're called GMCHs, or MCHs, but G meaning graphics memory controller hub, and to indicate the fact that graphics here is also associated with this memory hub. With more current implementations, we would also have something called the PCI Express interface here, and the PCI Express, which would be the X16 interface, which is what we use for a lot of the newer video, would also go through this interface right here. Then we have a hub interface, and now notice that we've been able to split things up a little bit. Notice that before we had to go through a PCI bus, which is now flipped around. Notice the PCI bus used to be up here, and then we'd have to compete with that before we'd ever get to the South Bridge. Well, now the South Bridge has been replaced with the I/O controller hub, and the PCI bus has been put down at the bottom here. The reason for this is because, remember, a lot of our components now are integrated, as opposed to non-integrated. A non-integrated motherboard would have been an old kind of motherboard that might have only had on the connectors on the back maybe a large keyboard connector of some kind. Now they're integrated, where we saw the whole block of connectors with USB and FireWire and all kinds of sound devices and all of that. Well, now that we've got so many of those things competing for space, what we can do is to put those separately here in a super I/O, which is going to be a faster interface, and we're going to put them closer to the CPU by not separating them with this PCI bus. However, we still have PCI slots, so these devices that we have in these PCI slots will still need to compete for access through what's been replaced by the South Bridge, now with the ICH, or I/O controller hub. But the architecture of this is simply going to be faster. Also, things like our LAN, Enhanced IDE, USB, these also are going to be a step closer to the CPU because they're now not separated by the PCI bus anymore. And then another way to describe this is called a hub architecture, whereas the other thing that we saw in the North Bridge, South Bridge architecture is called just that, a bridge architecture. Now here I've just gone back to this graphic of the ATX motherboard, and the only purpose for going here is to talk about troubleshooting now. Now with troubleshooting, there are a lot of different characteristics and principles that we'll use to identify where the problem is coming from. We discuss this later on in the series, sprinkled throughout many of the other topics. But in terms of troubleshooting the motherboard, if we've identified that it's definitely the motherboard problem, it's not the processor's gone bad, which we can just replace it. It's not just that one of these cables is loose on the back here, and we can just plug it in more firmly. Or a cable's loose over here on these serial ATA connections. We just need to press it into place. If we've confirmed that it's not something that's not misconnected or something that's not seated properly into a slot somewhere, and it's definitely the motherboard that's causing us the problem, I'm going to tell you real easy how to troubleshoot the motherboard. This is going to be just the easiest troubleshooting you ever heard of. What you do with this is you go down to the local electronics store and you buy another one and replace the old broken one. That's all you got to do. There's really nothing you can do with this. If there's a circuit in here somewhere, if a static charge hit this chip right here, for example, you don't take a soldering iron and melt all of this out, all the solders out, and then replace it with another one. Well, we don't have the capability for doing that. It's not a serviceable part. Most of this stuff on a motherboard is not serviceable. The plug-in components like the processor and memory, I must be getting late. But anyway, those are all serviceable. But the motherboard itself, not much you can do. You're just shucks out of luck if this thing goes bad, so you just replace it. In this nugget, we addressed motherboards, and we started off by taking a look at the various form factors, including ATX, Micro ATX, BTX, Micro BTX, and NLX. All of those are A+ exam objectives, so you need to be able to identify those visually. And then we took a look at riser cards, which are a big part of the NLX, and certain other kinds of implementations. The riser cards, of course, give us additional functionality that's not built into or integrated into the motherboard. And then we looked at chipsets as well. And these fall into two basic architectures, a bridged architecture using a North Bridge and a South Bridge architecture, which is a little bit older, but in principle it still works. And then we also used a hub architecture. We used a memory controller hub and an I/O controller hub for that. We took a look also at troubleshooting, which we saw just now was real easy, because if there's something wrong with that motherboard, there's really nothing serviceable on it. You pretty much discard it and get a new one. I hope this has been informative for you, and I'd like to thank you for viewing.